हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार। फ्रेंड्स, आइए स्टार्ट करते हैं दिस टॉपिक। कोफिशिएंट ऑफ परफॉर्मेंस COP ऑफ एयर रेफ्रिजरेशन साइकिल वर्कड ऑन बेल कोलमैन साइकिल और रिवर्स्ड ब्रेटन साइकिल और रिवर्स्ड जूल साइकिल। ओके, so friends, this is the TS diagram of the Bell Coleman cycle. In this process 1 to 2 is the isentropic process is done in the compressor. Okay, it will follow PV to the power gamma is equal to constant. Then process 2 to 3 is the constant pressure process followed in the cooler section. Okay, here what happened, heat rejection is there. Then in process 3 to 4 is the isentropic process is done in the expander section, and it will also follow, or you can say PV to the power gamma is equal to constant because it is isentropic, so it will follow PV to the power gamma is equal to constant. Okay, then in process 4 to 1 is done in the refrigerator section at constant pressure process, and here heat addition is there. So this is the TS diagram of the Bell-Coleman cycle. Now friends, we have to find the coefficient of performance of this cycle. Okay, friends, we know that compressor work done of compressor, how much is there? Enthalpy at point 2 minus enthalpy at point 1, it will give the work done of the compressor. So work done of the compressor is equal to enthalpy at 2 minus enthalpy at 1. Okay, similarly work done by the expander, it will be given by enthalpy at point 3 minus enthalpy at point 4. So work done of the expander is equal to enthalpy at point 3 minus enthalpy at point 4. So H3 minus H4. Friends, as we know that for ideal gas, because here air we are using and air is the ideal gas, so for ideal gas enthalpy is equal to Cp into T. Cp is the specific heat at constant pressure and T is the absolute temperature. Okay, so enthalpy equal to Cp into T. Getting friends? So in this case we will put here this value, enthalpy value, in the terms of temperature. Okay, so net work done, how much is there? Net work done is equal to work done on the compressor and work done on the expander. So we will minus it, this one. Net work input equal to how much? Work done on the compressor and work done on the expander. Okay, so here we are giving the work input and here we are getting the work done. Okay, because of the expansion of the expander. Getting friends? So work input is equal to work done in the compressor and work done in the expander. So we'll minus this one. So WC, this is the WC minus WE expander. Now we will convert this enthalpy in the terms of temperature. Okay, so here what happened? Cp into T2 and minus Cp into T1. So Cp we will common it, take common, so Cp in bracket T2 minus T1. Similarly here specific heat at constant pressure at T3 minus T4. Okay, so from here you see friends, Cp is constant, so and equal, so Cp we will take common, so T2 minus T3. Like here friends, what we will do, see here work input equal to, this is the work done in compressor minus work done in the expander. This is the net work done. And we know that work done in compressor equal to H2 minus H1 in bracket minus H3 minus H4. Okay. But we know that friends, this H is the function of temperature and H equal to this specific heat at constant pressure into temperature, absolute temperature. So here this H2 value is equal to how much? Cp into T2. H1 value is equal to how much? Cp into T1. H3 value is equal to Cp into T3 and H4 equal to Cp into T4. Okay, we will put all this value in the equation, in this equation. So what we will get friends? What we will get? W input net equal to how much? H2 minus H1. So this Cp T2 minus Cp T1, okay, minus here this Cp T3 minus Cp T4. Okay, so Cp and Cp is constant and it is equal, so we'll common it this one. So T2 minus T1 minus here also we'll take common, so T3 minus T4. Okay, now friends, again we can take common here, so Cp this T2 minus T1 minus in bracket T3 minus T4. Okay, if you remove the bracket, then what happen? This minus and here it will come plus. Okay, getting friends? So T2 minus T1 minus T3 plus T4. Now friends, here you see this you take common here, so T2 minus this term we will combine T3 and here this minus T1 plus T4. Okay, just this minus term with I did here and this minus T1 I did here. Okay, nothing changed. So here Cp common. See here we will combine this one, this T2 minus T3 minus, will take minus common here. So what happened? T1 minus T4. Okay, so this is the net work done. W input, this is the net. Okay, so I directly put it here, the W input is equal to how much? This is the net Cp T2 minus T3 minus T1 minus T4. Okay, this value I written directly here. So how it is coming? W input net equal to Cp T2 minus T3 minus in bracket T1 minus T4. Okay, this is the net work done. Now what is the refrigeration effect? What is the refrigeration effect? Why we are going to find friends? Why we are eager to find this work input and refrigeration effect? Why? Because we know that friends, this COP equal to refrigeration effect upon work input. Okay, so already we find what is the work input, then we will find the refrigeration effect, then from here we can find the COP. Okay, now friends, what is the refrigeration effect? What is the refrigeration effect? Friends, this is the refrigeration effect because here you see heat addition is there, and this heat addition is the refrigeration effect. How much is there this heat addition? H1 minus H4. So enthalpy at point 1 minus enthalpy at point 4, it will give the heat addition or refrigeration effect in this case. Okay, so how much is there? How much is there? This heat addition or refrigeration effect is equal to Q addition is equal to how much? Enthalpy at point 1 minus enthalpy at point 4. Okay, so similarly here we will put how much? This Cp T1 minus Cp T4, and from here this refrigeration effect is equal to Cp common T1 minus T4. Okay, this is the refrigeration effect. Okay, now COP equal to refrigeration effect upon work input. So refrigeration effect is equal to how much? This Cp T1 minus T4. Okay, and work input is, friends, work input equal to how much? Cp in bracket T2 minus T3 bracket close minus this T1 minus T4 bracket. So how much is there? This Cp T2 minus T3 in bracket minus T1 minus T4 in bracket. So this is the work input. Okay, so from here Cp to Cp cancel out. What is left? This term left. But what I am going to do, friends, I will common this one T1 minus T4. I will take common from this whole bracket. So what is left here? This T1 minus T4 on the top side. This is left on the top side. Bottom, I am going to common this one. So T1 minus T4 I am taking common. So what is left? This T2 minus T3 divide by T1 minus T4 minus 1. Okay, so here also you see this T1 minus T4 and T1 minus T4, it will get cancelled out. Okay, it will get cancelled out, friends. Then what happened? What is left here, friends? What is left here? This COP equal to here 1, then in bottom T2 minus T3 divided by T1 minus T4 minus 1. Okay, any confusion? I think it should be clear, because here 1 left into 1 and here this will cancel out. So 1 upon T2 minus T3 upon T1 minus T4 minus 1. Okay, now friends, one more point we will do. Friends, here this 1 upon this term is there. So T2 will take common from this point and T1 will take common from bottom point. So if you take common T2, then what happened? 1 minus T3 by T2. Okay, and from bottom side T1 take common. So T1 equal to how much? T1 equal to 1 upon T4 divided by T1. Okay, so this is minus 1, this term, and in the bracket. Okay, nothing, just I common this one T2 from here and T1 from here. Okay, this is the COP, nothing else. This is very simple, friends. COP equal to refrigeration effect upon work input. We will put the value, whatever cancel out term is there, we will cancel out. Then what is left? This is the temperature. This is the temperature left here. So I common it T2 here and T1 here. Okay, up to this I think no confusion should be there. Okay, now friends, what we will do, we will find the value of this one, 1 minus T3 by T2 and 1 minus T4 by T1. Okay, how we will find? Just you see. Okay, friends, here you see this process. Process 1 to 2 is the isentropic process. So here S1 is equal to S2, because entropy at point 1 is equal to entropy at point 2. Okay, So this is the isentropic process. Okay friends, so what we will do, process 1 to 2, in process 1 to 2, what happened in process 1 to 2 is the isentropic process, tropic process. So temperature at point 2, we will find the relation between temperature and pressure because it is the isentropic process. So T2 upon T1 equal to P2 upon P1 to the power gamma minus 1 upon gamma, because we know that when the process is isentropic, so the relation between temperature and pressure is like this: T2 upon T1 is equal to P2 upon P1 to the power gamma minus 1 upon gamma. Okay, so this press P2 upon P1 is the pressure ratio, pressure pressure ratio, and it is denoted by rp. Okay, so P2 upon P1 is the rp, is the pressure ratio. So this T2 upon T1, this T2 upon T1 equal to rp to the power gamma minus 1 upon gamma. Okay, from here we are able to find one relation. Now similarly you see here in process 3 to 4, it is also isentropic process and it will follow Pb to the power gamma is equal to constant. So from here friends, from we can say from process 3 to 4, because it is also isentropic process. So T3 upon T4 is equal to P3 upon P4 to the power gamma minus 1 upon gamma. And friends we know that what, pressure at point 2 equal to pressure at point 3. So P2 equal to P3 and P4 equal to P1, because we know that friends, this is the TS diagram, and this is the pressure versus volume diagram. So here P2 is equal to P3, and because pressure is constant now, pressure is constant, so P2 is equal to P3. This pressure is constant pressure follow in the cooler and constant pressure follow in the here refrigerator. So P4 is equal to P1. Okay, so friends, this P2 is equal to P3 and P4 is equal to P1. So from here we will put it this P2 upon P1 to the power gamma minus 1 upon gamma. And we know that friends, P2 upon P1 is the pressure ratio Rp. So Rp to the power gamma minus 1 upon gamma. This is T3 by T4. So from here you see friends, this relation, and if this is A and this is equation B, so from equation A and B, what happened? This T2 by T1 equal to T3 by T4. Okay. And from here, what we will get? This term just exchange, just cross multiply. We can say this T4 will take here and T2 will take here. So T4 by T1 equal to T3 by T2. So just interchange here. Okay. And we will get this term T4 by T1 is equal to T3 by T2. Okay, this is the important term. Okay, so what we will do, if we will take both side minus, then what happen? 1 minus T4 by T1 equal to 1 minus T3 by T2. No problem will be there. Okay, both side taking we are minus now. Getting friends? So now why I am doing this one? Why I am doing this one friends? Because in the COP just you see 1 minus T2 by T 1 minus T3 by T2 and 1 minus T4 by T1, and from here what you say, what we are seeing, 1 minus T4 by T1 equal to 1 minus T3 by T2. So it means this term is equal, so it will cancel out. For cancelling this one, we are doing these things. Okay, for cancelling this one, we are finding this relation. Okay, so what we will achieve, friends? What we will achieve, 1 upon this T2 upon T1 minus 1. This is the COP. And we know that, friends, the T2 upon T1 is equal to pressure ratio gamma upon Rp to the power gamma minus 1 upon gamma. So we will put this value 1 upon Rp to the power gamma minus 1 upon gamma minus 1. This is the COP. Okay, this we have to derive COP in the terms of Rp. So derive, question is derive COP of air refrigeration cycle in the terms of pressure ratio Rp. Okay, like here, friends, the question is asked, air is used as refrigerant in the reversed Brayton cycle or reversed Joule cycle or Bell-Coleman cycle. Draw the TS and PV diagram for the cycle and derivate COP in the terms of pressure ratio Rp. So COP is equal to how much? 1 upon Rp to the power gamma minus 1 upon gamma minus 1. So we have to derive this equation. Okay, getting, friends? So now we derived here COP equal to 1 upon Rp to the power gamma minus 1 upon gamma minus 1. Okay, friends, any doubt you can ask me in the comment box. आपको किसी पॉइंट पर समझ में नहीं आ रहा हो तो आप मुझे कमेंट बॉक्स में पूछ सकते हैं, मैं इसको एक्सप्लेन करने की पूरी कोशिश करूंगा। फ्रेंड्स अगर मेरा एक्सप्लेनेशन आपको अच्छा लगे तो प्लीज लाइक कीजिए, कमेंट कीजिए, मेरे चैनल को सब्सक्राइब कीजिए फ्रेंड्स। थैंक यू।